Welcome back. In this video, we will be discussing how to manipulate equations. Equations are the foundation of general chemistry, and being able to rearrange and solve for different variables is a fundamental skill. Our first example of this is the temperature conversion from Fahrenheit to Celsius. The Celsius scale is the international standard of temperature, whereas Fahrenheit scale is primarily used in the United States. It is important to be able to convert temperature from one scale to another. The equation for this is our temperature in Fahrenheit equal to the quantity of our temperature in Celsius times 9 degrees Fahrenheit divided by 5 degrees Celsius, and that quantity plus 32 degrees Fahrenheit. If the temperature is given in the Celsius scale, then it's merely a matter of solving for the temperature using our order of operations. If the temperature is given in Fahrenheit, however, then the equation can be rearranged to solve for the temperature in Celsius. In order to accomplish this, we have to do our order of operations in reverse order. The first step is to subtract 32 degrees Fahrenheit from both sides of the equation in order to move it from the right side to the left side. You will now see that my 32 degrees Fahrenheit minus 32 degrees Fahrenheit is going to be equal to 0 and cancel out. Now that we have parentheses isolated on one side, we have to break into these in order to manipulate that side. When doing so, we must create parentheses on the left side, giving us our equation of TF minus 32 degrees Fahrenheit equals our temperature in Celsius times 9 degrees Fahrenheit divided by 5 degrees Celsius. The right side now contains the multiplication of a fraction. In order to isolate the variable we want, we need to divide both sides by this fraction. You will notice that the two fractions located on the right side are going to be equal to 1 and cancel out. Now we have the division of a fraction. In this case, what we are going to do is multiply by the flipped version of our equation. We have the variable we want isolated, and we can now plug in our temperature in our Fahrenheit scale into the rearranged equation. Let's try another one, but this time we will combine two different equations. Those equations are C equals lambda times nu and E equals H times nu. The top equation is going to use the speed of light, c, lambda, which is going to be our variable for our wavelength, and finally nu is going to be our variable for frequency. The second equation, commonly called the Planck equation, relates the energy of light to its frequency using what we commonly call the Planck constant. How can we combine these two equations together? The most common way is to look for a common variable. If we solve for nu in the first equation, we are going to be able to do this. This is done by dividing both sides of our equation by our lambda. We are able to now isolate our value for nu, and it is c divided by lambda. We can take this equation and now plug it into our second equation for our value of nu. This gives us the combined equation that we want, and the value is hc over our lambda. This equation, commonly called the combined Planck equation, allows us to solve for the energy of light directly from the wavelength. The last example I will now show you is how to rearrange equations with exponents. The equation used to determine this is the velocity of a gas particle. Velocity, RMS, equal the square root of 3RT over mm. VRMS is the average velocity of a gas particle. R is known as our gas law constant. T is our temperature. And mm is the molar mass of the gas particles. What if we have the average velocity, but we want to solve for the molar mass? The first thing we must do is get rid of the square root. A square root is just another way of writing to the 1/2 power. Now we can see how squaring both sides of this equation gives us our VRMS squared on the left side, while we're going to have the powers of 1/2 and 2 canceling each other out. This will result in an equation of VRMS squared being equal to 3RT over mm. Now we have to multiply both sides by the molar mass to get rid of it and get it out of the denominator. Our two mm's on the right side are going to now cancel out. Finally, the last step I must do is divide both sides by VRMS squared in order to isolate the molar mass that we just moved. We have now isolated the variable we want in the molar mass. And the final equation that we want is molar mass being equal to 3RT over our VRMS squared. In this semester of chemistry, you will learn many more equations, and the skills of equation manipulation, combination, and removing the exponents are going to be an essential skill.